Let's have a look at an application of a redox reaction. So corrosion by definition is the deterioration of a substance, usually a metal, by an electrochemical process. In other words, we get the deterioration of a substance through a redox reaction. And the common ones that we come across are the rusting of iron, the oxidation of copper and aluminium. The most common one, and the one that millions of dollars is spent on preventing, is the rusting of iron. For rust to occur, we need two things present. We need a source of oxygen and we need water. And the product of rust is iron 3 oxide. And this iron 3 oxide is commonly found with some sort of multiple of water molecules attached as well. And that X, the number of water molecules that can change, gives us distinctive colours of rust. So we can have yellows to reds to oranges, which are the common ones that we see, but we can also have green and black rust as well. And those colours are determined by the ratio of water for every iron 3 oxide molecule. Now the process is quite complex. We start with our iron molecule, that's oxidised to iron 2+, and that's further oxidised to iron 3+. We also have our oxygen molecule, that's reduced to a hydroxide molecule, and then further reduced to an oxygen 2- molecule. And as our final reaction, we get 4 lots of iron plus 3 oxygen molecules, gives us our 2 iron 3 oxide molecules. So how can we prevent rust? There are two quite common ways of preventing rust. The first two is apply a coating, and that coating will exclude oxygen and or water. The problem with this coating is if it's scratched or slightly removed, rust will still occur at a stress point or a scratch. The second form of prevention of rust is what we call a sacrificial anode, and it's a redox reaction. In this case, in all cases, the sacrificial anode supplies electrons to the iron. And we typically choose a metal that's more easily oxidized than the iron is. So in this diagram, I have my iron, and that could be a ship floating on the ocean, it could be a pier, it could be any number of things that are exposed to the elements in iron as an iron atom. And what we do is we connect our sacrificial anode to our iron, and in this case we use magnesium. Zinc is another common sacrificial anode. And the process is that the magnesium is preferentially oxidized to give us magnesium ions and our 2 electrons, and those 2 electrons will flow from the magnesium to the iron. And this ensures that our iron, by accepting those electrons, will be kept in a reduced form.